So I'm going to start out with just a situation. So let's suppose that we have a Ferris wheel. You guys all know what a Ferris wheel is. So a Ferris wheel is this big round wheel at a circus or something like that, or a carnival. Has an axle. It's got supports that hold it up in the air, and then the ground is down here someplace. And then it has some kind of car or seat that people ride in. And the problem that we're going to do is we're going to consider the case where we have a Ferris wheel that its diameter is 190 feet, which a lot of famous Ferris wheels are very large. And then it's about 10 feet off the ground. So there's a ramp that people have to go up to actually get onto it. Okay. And then that's what we're going to be given. And then I'm going to tell you how fast it rotates. So the Ferris wheel rotates at 1 revolution per minute. Okay. And the question that I'm going to be asking is, what is the height spelling of a passenger at time t minutes after they board? Okay, and we're going to assume, just to make it easy, we're not going to wait for every seat to get filled, or we'll just take the case where it's the last seat that got filled that we're watching. That way, because it's in reality, a Ferris wheel moves forward to the next seat, then moves forward to the next seat, then moves forward to the next seat, loads and unloads. Then it starts turning at the last one. So we'll take the instance where it's starting with the person who just got on, and now it's going to start rotating around. And Ferris wheels turn at almost constant velocity, even when they're starting up, because they don't turn really fast. So we'll just assume constant velocity. So we want to find out the height of the passenger any time. And so that means we're going to have to write an equation. And that means we need to understand that this is going up and down and up and down and up and down relative to the ground. So this seat will be climbing. It'll reach its highest point and it'll go back down. And so if I was to actually graph the height of that seat over time, so if I took that and I graphed it over time, and there would be some maximum height that it reaches, and there'd be some minimum height that it reaches. And so what kind of a shape will this be? More specific. Has a name. Starts with an S. Sinusoidal. Yes. Okay. So this graph will be sinusoidal. And that means it's going to, but in this case, sine normally starts at the midline. And this doesn't start at the midline. That tells me that if I want to make my job easier, I'm not going to use the sine function. I'm going to use cosine, because cosine would start at the highest point, and I can just easily flip it upside down. But it's going to start when the Ferris wheel starts turning. That seat will start down here. It'll start rising. It'll reach the middle when it reaches here. and then it'll go up to the highest point, and then it will start coming back down. Eventually, it'll reach the bottom again, and then it'll just keep repeating this pattern over and over, and it does create a true sinusoidal graph. I don't know if you guys remember, but we graphed using parametric functions. We graphed a full circle using just sine and cosine, and that's actually what's happening here. We're really just orbiting around the unit circle, and so this graph is what we're going to get. And except it's not a unit circle, so we're going to need to figure out what is the highest point. So that's 190, and that's 10, so this would be 200. And then this is, well, this is going to be 10. But I really need to know the midline because that's the vertical shift of the graph. And to find that, I need to know the radius of this. So I'm going to calculate the radius, and the radius would be half of 190. So in this case, the radius is going to be equal to 95. And that tells me that I go up 10 feet to get to here, and I go up another 95 feet to get to here. 10 plus 95, that means I'm at 105. So that I have that piece. And I have another piece of information. I know that the period, if I look at this graph, I know that it goes through 1 complete revolution per minute. So this would be 1 minute right here. Here's time 0. We have 1 minute for the period, and it's going to come back down to the bottom. And so I can actually start thinking about the variables that would go into my equation. I'm going to go ahead and write a function, the height based on time. I know that I want to use cosine, and I'm just going to write out the graphing form of a sinusoidal graph using cosine. And then I need to figure out what these variables are. So A is the amplitude, and the amplitude is always going to be the radius. So the amplitude is the radius, and it would be in this type of a problem. And so it would be 95. And B is not the period, but it is 2 pi divided by the period. So if I go look at the period here, period is 1 minute. And so 2 pi divided by 1, so B will just be 2 pi. Phase shift, well, cosine starts right there if I flip it upside down. So if I flip the graph, it would be 0. If I don't flip the graph, then I'm going to have to shift up to here, and that would be 1/2. So the C value would be 1/2 if it's not flipped. So if I flip this, then this becomes it. These are going to be, this sign right here will be related to this. So the phase shift, you can either flip it or you can shift the graph. One or the other. Either will always work as long as you do it correctly. And then last but not least, the vertical shift, D, that is the midline, so 105. So to wrap this up then, my entire equation then, h of t, so it'd be negative 95 cosine And I would say the flipping is always easier than the phase shift. There's more opportunity for error with phase shift. And then B is 2 pi. X. We didn't shift it at all, so I could actually put -0 here or just put X and be done with it. And then plus 105. And so this would be an equation that tells me exactly what height I'm at after a certain amount of time. And I can check my work by going to a calculator, plugging in, let's say 1/2, for instance, and see if I get 200 out. So if I plugged in 1/2 here, 1/2 times 2 is just 1. So I'd have the cosine of pi. Cosine of pi is -1, if you look at your unit circle. -1 times 95, or -95 is +95. 95 plus 105 is 200. So I was able to check my work.